All right, our next video is going to be on factoring, which is certainly one of the tougher topics we handle just because there's no like, hey, you do this every time and you get it right. But I am going to try and give you some hints on these problems to make factoring a little bit easier for you. The first problem is the simplest factoring, and please be aware that this is considered factoring, and that's taking a GCF out. Okay, if you take a GCF out, that is factoring. So in this first problem, the biggest number that goes into 6 and 18 is 6. And if you have two of the same variable, what we do is we take out the lower exponent. So here we have x to the fifth, here we have x to the fourth. You can't take something out that you don't have in both terms. So you can't take an x to the fifth out of both terms because you don't have x to the fifth here. But you could break down x to the fifth as x to the fourth times x to the 1. So you can take an x fourth out of both of them. So we take a 6x to the fourth out. 6 divided by 6 is 1, and we're left with an x behind, so it's just x. And then here, the x to the fourth comes out, but 6 out of 18 is 3, and we get x plus 3. Keep in mind, we're not changing the value of anything. Okay, if I were to plug a 1 in for x, I would get 24 in the original one. And if I plugged 1 in for x down here, I would also get 24. So we're really just simplifying. We're not solving anything. The second one, anytime there's two terms and a subtraction sign, we should be looking for a difference of two squares, which means there's no middle term. There's no x term, or you could write it as 0x if it makes you feel better or you kind of like the look of it. Okay, but once again, our first rule of factoring is always to take a GCF out. In this case, we take a 5 out, and we're left with x squared minus 4. And when I break it down even further, x minus 2 times x plus 2. Because if you FOIL this back, you'd get x squared plus 2x minus 2x, which cancels, and then negative 2 times 2 is negative 4. Keep in mind, factoring is a guess and check sort of game. Okay, but whenever there's no middle term, chances are we're just going to take the square root of this term. And chances are it'll be a perfect square. Doesn't have to be, but a lot of times it will be. And if it's not, you're not going to be able to factor it anyway. In number 3, once again, we take a 3 out and we're left with x squared minus 5x minus 24. Anytime you have no coefficient in front of x, it makes life a little easier. Right away, I can put my x's here and here. Okay, because the only thing that's going to create an x squared is x times x. There really is no choice. And now I start looking at my factors of negative 24. Well, what factors of negative 24 can combine to be negative 5? I'd probably start by trying 6 and 4, but there's no way to combine 6 and 4 to get negative 5. But the next terms would be 8 and 3. And 8 and 3 can combine to be a negative 5. Put a negative 8 in and a positive 3. Once again, the better we get, the more educated our guesses can be. And then our last one, we can take a 4x out of all three terms. And we're now left with 2x squared plus 11x plus 12. Now another hint here, 2x is a prime number. Or 2x squared is, well, 2 is a prime number. So right away, I can put 2x and x in these two spots. Because when there's a prime number here, you only have one option. It's got to be 2x and it's got to be x. Now, could you have put the x here and the 2x here? Yes. But the x and the 2x were these two terms here. We have options for 12, though. We have 1 and 12, we have 2 and 6, and we have 3 and 4. Another hint I can give you is there's never a GCF when you factor in a parenthesis. So there's no way this could be 4. And if we were trying 6 and 2, whether I put a 6 or a 2 here, it would never work. So I don't even have to waste my time trying 6 and 2. But when I use 3 and 4, if I plug the 3 in here, I know I do not have a GCF here. And therefore I can put the 4 there. And when you FOIL it to check it, 2x times 4 is 8x. 3 times x is 3x, 8x, and 3x is 11x. That's the last thing, is you really only need to check the middle term, because if 2x times x didn't equal 12, and 3 times 4, 2x times x didn't equal 2, and 3 times 4 didn't equal 12, you wouldn't have tried it anyway. So really, when you check these problems, you literally just have to check to make sure your middle term works.